This is the lecture for lesson 25. The first part of this lecture is going to cover circles. So we're going to put an equation into standard form, and then we're also going to have an equation in standard form and be able to graph the circle. In order to be able to get an equation of a circle in standard form, we have to use a process called completing the square. So what we're going to do here is we're basically going to rearrange, put all of our x terms together, put all of our y terms together. I know there's not any y terms on this slide, but you're going to get all of them together and then number on the right side. What you're going to do then is add this term to each of the sides. So for each group, so maybe x here, we have x squared minus 6x. Well, if I take 6 over 2 and I square it, 6 over 2 is 3, 3 squared is 9. So you can see that they added 9 to both sides of the equation. Why did we do that? Well, because we created a perfect square trinomial here now. And this can be factored using what we know from before, that to multiply to 9 and add to negative 6 is negative 3 and negative 3. So it's a perfect square. So we can factor it, x minus 3, which is x minus 3 squared. And then on this side, we can just add whatever we have left. So we're going to practice this process quite a few times with both x's and y's, and hopefully you'll be able to understand how it works. So we are given 3 equations here that are not in standard form, and we want to put them in standard form, which is vertex form. So basically we can pick out the vertex and we can pick out the radius, and it makes it really easy to draw our circles. So I'm going to start with A, and what I'm going to do is I'm going to move the x's together. So x squared plus 8x. I'm going to do plus, and I'm going to put a blank. Now I'm going to do the y terms. So y squared plus 4y, I'm going to do plus blank. And then on the other side, I'm going to move this positive 16 over. So negative 16. And then whatever I add in blue, I'm going to add over here. And whatever I added for purple, I'm going to add there as well. So how do I determine what I add? Well, you're going to take this term, the second term, the single variable term, so 8, half of 8. 8 divided by 2 is 4, and then I'm going to square that, 16. So in the blue spot, I'm going to put 16. And I'm going to do the same thing with the y's. So I'm going to go to my y term, and I have 4y. Well, half of 4 is 2, and I square that, I get 4. So I'm going to put the 4 then there. Now, I can go and factor, because this should be the same term. What did I do when I got this? Well, 8 divided by 2 is 4, and 4 squared is 16. So this is x plus 4 quantity squared. The factors are 4 and 4, exactly the same. And for the y's, when I did 4 divided by 2, I got 2. So there's my factor, y plus 2, quantity squared. And then on the right-hand side, I'm just going to add these together. So negative 16 plus 16 is 0, plus 4 is 4. And that one is done. Okay, so I'll take B over here, and I'm going to move, again, the x's together. So x squared minus 4x plus blank. I have y squared minus 12y plus blank equals, I'm going to move this negative 9 over, so it becomes positive 9. And then whatever I fill in the green blank, and whatever I fill in on that mustardy kind of blank. All right, so starting with the x term, I have a negative 4. Negative 4 divided by 2 is negative 2. So that's my factor, x minus 2 squared. That's what I want. Well, negative 2 squared is 4. So if I add that there, I'm going to add that over here. I'm going to do the same thing with the y's. So negative 12 divided by 2 is negative 6. That's the factor I want. So in order to get that, I have to take negative 6 squared and get 36. And that's what's going to be on the right side that I have to add. If I add 9 plus 4 plus 36, I get to 49. And that is my equation. Now we have one more that we're going to do here. And I'll bring this down. So all I have is an x squared. There is no x term, so I'm just going to leave the x squared as it is. That means there's nothing more that I can do with that piece specifically. So I'll carry the y's down. Y squared minus 6y. So I'm going to have to fill in the blank. Now this negative 7, I'm going to move to the other side as positive 7. And then whatever I fill in the blank for the y, I need to add over here. So starting with my x squared, there's nothing to do with that x squared, so I'm just going to leave that as is. Now, for the y's, if I take negative 6 and divide by 2, that gives me negative 3. So it's going to be y minus 3, and then I want to quantity square that, so that's going to give me 9, meaning I'm going to add 9 over here. So we have x squared plus the quantity y minus 3 squared equals, if I add these two together, I'm going to get 16. And this is the way we want all of our circles to be written because it gives me my center and my radius. Now we have our equation in correct form. So this is standard form. X minus h quantity squared plus y minus k quantity squared equals r squared. What we can do is we can pull out the center, which is going to be h, k, and then the radius is r. We can then draw our circles with that information. Our first equation here is x squared plus y squared equals 49. So the most simple form we have anything added to the x value. We have nothing added to the y value. So that means our center is at the origin 0, 0. And the other thing we need to get is our radius. Well, 49 is the radius squared. So that means the radius then is the square root of 49, or 7. So what I'm going to do first is plot my center, 0, 0, and then I'm going to count out 7, up, down, left, and right. 1, 2, 3, 4, 5, 6, 7. So that's all the way to the edge of my graph. And I'm going to do my best attempt to turn this into a circle. And there you go. So let's look at the second one. The second one is x minus 2 quantity squared plus y minus 3 quantity squared equals 16. So to get the center, you're going to take the exact opposite what's here. So if it says minus 2, it's 2. If it's minus 3, it's 3. And then we need our radius. Well, the radius squared is 16, means the radius is the square root of that, or 4. So I will first find the point 2, 3, and then I'm going to count 4 in all 4 of those directions. Up, right, down, and left. And again, do my best attempt at making a circle. As you work through it, you'll get a little bit better at drawing them, but do know that mine are not perfect either. So do your best. And our last one here, so we have x plus 4 quantity squared plus y plus 5 quantity squared equals 36. So remembering that our center is the opposite of what's listed. So if it's plus 4, it's negative 4. If it's plus 5, it's negative 5. And then the radius, we take 36 and square root it, so that's going to give me 6. Now, in order to make this work here, I'm going to tell you that my scale is going to be by 2s. So everything's going to count by 2s. So 2, -4, 2, 4, and then 5 is going to be right in the middle. And then I got to count 6 in both directions. So 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. And then I'll do my best again to make my circle. And that is circles. The next part of this section is going to talk about ellipses, which you may be a little more familiar with as the shape of an oval, but it has a special name called an ellipse. We will identify key points from a graph, key points from the equation, write an equation in standard form when it's at the origin, and then graph those ellipses as well. This is an example of an ellipse, and you'll see everything labeled on here. The first thing you're going to do is find your vertex or your vertices, and your vertices are going to be, they can either be x's or they can be y's. It depends on which of them is larger. So the larger is the vertex. And then in the opposite direction, we have our co-vertices or co-vertex. That means the vertex is called our major axis. That's our larger version, larger where it's stretched. And then the minor axis is our co-vertices. The center is going to be in the exact middle. And then we're also going to have focus. And since there's 2 of them, they are called foci. Here we have 2 ellipses drawn, and they want us to find, in this first one, the vertices and the foci. So what I need to do is I need to look at my graph, and you can see the larger stretch is here. And that is right between 4 and 6, and -4 and -6. So the vertices are, that's going to be 5, 0, and -5, 0. It's going to be a reflection on both sides. So if it's +5, it's also going to be -5. Foci, or the foci, however you want to write it, we can see that one's labeled here as the square root of -√21, 0. -√21, 0 means that on the right-hand side, the foci are going to be +√21, 0. We can look at the next graph here. So our vertices are going to be the ones that are stretched further. So that is labeled 0, 7. So 0, 7 also means that the opposite one, 0, -7, because they should be exactly symmetric. And then this one asks for the co-vertices. So that one's the shorter span. That's 3, 0. So then this is -3, 0 on the other side. So 3, 0, -3, 0. They're going to give you a marking for at least one of them so that you can then label what the other one is. On this slide, you're going to see a table that you're probably going to want to have a copy of when you're doing the homework and then when you're doing the test. Because what it does is it lists the standard form of an ellipse whose center is at the origin. And that's the only ellipses we're going to do, centered at the origin. And it gives us both versions for where the major is on the x and when the major is on the y. Now, the key to know which one is which is a is bigger than b. So we're going to have x squared over a squared plus y squared over b squared equals 1. Or it's x squared over b squared plus y squared over a squared equals 1. If we have the first option, that means our major axis is the x-axis. So a is bigger, it's under x, there's our major axis. The length of the major axis is going to be 2 times a, and the coordinates of the vertices are -a to 0 and a, 0. That means the minor axis length is 2b, and the coordinates of the co-vertices are going to be 0, -b, and 0b. So this will be the x. It's going to be one of these, stretched more in the x. And then we need to also be able to find our foci, however you want to say it. And that's going to be with a c value that we calculate using this formula here. C squared equals a squared minus b squared. We're going to solve for that c, and that's going to tell us how we find our foci. That's going to be negative c comma 0 and c comma 0. If you are given the a, or the larger value under the y term, we are now going to have an ellipse that is stretched vertically, meaning our major axis is going to be stretched in the y direction. The length of that axis is still 2a. The difference now is the vertices are 0, negative a, and 0a. So they're now y values instead of x values, which means that your minor vertices, your co-vertices, are going to be the x values going this way. And the foci are, again, going to be solved by finding c, and then they're always in the direction of the major stretch. So 0, negative c, and 0, c. So what I have for you here is that I'm going to kind of keep just a different table here version so we can practice finding the vertices, co-vertices, and the foci. For the first one, we have x squared over 36 and y squared over 9 equals 1. The larger one number is under the x. So that means our vertices are going to be on the x, the horizontal one, this guy here. We need to figure out here what a and b are. So right now, a squared is 36. That means a is 6. B squared is 9, which means b is 3. So our vertices following our formula here is a, 0, so 6, 0, and negative 6, 0. Our co-vertices are going to be then 0b and 0, negative b, so 0, 3, 0, negative 3. And then the foci, we need to find c first. So that is c squared equals a squared minus b squared. A squared is 36, b squared is 9. So c squared equals 36 minus 9, or c squared is 27. So I would have to square root, and 27 can be broken down into 9 times 3. I can square root 9, 3. I cannot square root 3, so c is 3 root 3. Meaning our foci are 3 root 3, comma 0, and negative 3 root 3, comma 0. Next one over here has x squared plus y squared over 100. Now, if the number is not over, if your variable is not over a number, it's technically over 1. So a squared is always the larger number. That is 100, which means that is under the y squared. It means we're now going to be stretched vertical. So this guy means b squared is 1. So a is 10 and b is 1. Square root of 100 is 10. Square root of 1 is 1. So our vertices are going to be, in this case now, the y values. So 0, 10, 0, negative 10. Your co-vertices are going to be the x values, so 1, 0, and negative 1, 0 based on b. And now we're going to solve for c. So c squared equals a squared, 100, minus b squared, 1. C squared is going to equal 99. So if I do 99, that's 9 times 11. If I square root both sides, I can square root 9, gives me 3. I cannot square root 11. So c is the value 3 root 11. And they're going to be y values on this guy. So 0, 3 root 11, and 0, negative 3 root 11. Now I'm going to give you the vertices and co-vertices, and you have to create the equation. In number 5, asks for the standard form of the ellipse where our vertices are -9, 0, and 9, 0. So our vertices are on the x-axis using an a value of 9, -9, 0, 9, 0. And the co-vertices are then a y value, 0, -4, and 0, 4, meaning b is 4. So all I need to do then is put my equation together. X squared is going to be over a squared. 9 squared is 81. Then y squared is going to be put over b squared. 4 squared is 16. And it's always set equal to 1. For 6, we have vertices again on the x-axis at -10 and 10. So that means a is 10. And our co-vertices are on the y. 0, -8, and 0, 8 means b is a distance of 8. So we're going to put x squared over a squared. 10 squared is 100. And y squared over b squared. 8 squared is 64. And set it equal to 1. Now that we know how to get the vertices and the foci from our equation, we're going to go the last step and graph. Looking at the first one, we have x squared over 25 plus y squared over 16 equals 1. The larger number is under the x term. So our vertices are going to be on the x. That means a is 5. So that's going to be 5, 0, and -5, 0. Working with our co-vertices, that's the other variable here. So we have b equals 16. Sorry, b squared is 16. So b is the square root of that, or 4. So that's going to be on the y value. So 0, 4, and 0, -4. And then we also need to find our foci. We're going to do that by taking a squared minus b squared. So 25 minus 16. So c squared equals 25 minus 16. That gives me 9, which comes out nicely. Square root of that is 3. So our foci then are along our x-axis here, 3, 0, and -3, 0. So we'll start with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. So I'll do my best to kind of make the oval shape here of my ellipse. And then I just need to add my foci. And I am done. Depending on the difference between these values, it may be more stretched or less stretched. For b, we have x, that should say x squared. I'm sorry about that typo. X squared over 49 plus y squared over 81 equals 1. So a squared is always the larger number. In this case is 81. Square root of that is 9. And then b squared is 49, so square root of that is 7. This is on the y. This is on the x. So our vertices are going to be 0, 9, 0, -9, y coordinates. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the x's are going to be on 7. So 7, 0, -7, 0. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Do your best to make it look oval-like. And then the last thing I need to do is find my foci. So I got to do this c squared equals a squared minus b squared. So it's going to be 81 minus 49. When I subtract that, I get 32. So if I square root 32, let's see, that's 16 times 2. I can square root 16 for root 2. And they're on the y-axis. So 0 for root 2 0, negative 4 root 2. Now, you look at that number and then you say, I don't know what that is. So if you go to your calculator and go back and type in the square root of 32 or 4 square root 2, you're going to get about 5.6. So that's going to at least help me plot the point here. 1, 2, 3, 4, 5.6. 1, 2, 3, 4, 5.6. And that is the end of this section.